Good morning. Hey, Kym.
Good morning, Renee.
How are you doing?
I'm good, thank you. I'm very good.
So just a quick information in case you missed it, we are live.
Ah,
okay.
Fantastic. Was I getting something, was I?
Yeah, just thanks for being back on the second. I appreciate that. I was scared here for a second losing you. Yay. So this is our second try of doing something that I brought up weeks, it feels like months ago, probably it was months. And it is something that, let me quickly introduce this before I introduce Kym. So is this something that when I watched my son doing his homework, I found like, hey boy, what are you doing there? And he was trying to find some words in a puzzle, and we're gonna go into some detail. And he asked me for help, and while I was trying to help him, I was not really with him, and I figured, well, maybe we can write some sort of program to solve this puzzle. And so he kept bugging me saying, hey, can you please help me now? And I'm like, yeah, sure. So what I want to show you today, starting today, we're going to make this a multi-week stream, is how I totally over-engineered a Azure-based solution to solve a very simple problem that my son had during his homework. And Kym is here today. Welcome, Kym. Because
welcome.
Kym, you helped me a bit with this, with solving this. So Kym, maybe you want to introduce yourself quickly? Where do we know from each other?
We know each other from Xamarin University. So we were both Xamarin University instructors. Now we sort of work on the Learn platform as senior content developers, I think. But yeah, we met at Xamarin University. I think you were working there quite a while before I was. But yeah, so my background is pretty much C# mobile development. Yeah. So
same here. That was 2014 when I started.
Yeah, I think I might have been 15. When was the first Evolve?
The first Evolve, I just tweeted that yesterday, my favorite Evolve, that was 2013. Were you there?
No, I just missed it.
You missed it?
So,
oh, missed it. That was the best of all, of course.
That's what everyone tells me. But I was there for the second one.
Right. Yeah, that was fun. Where was the second one? First one was Austin. Second one was in
Orlando.
Was that Orlando?
I don't know, but it was E16.
No, the second one is not. Is that 16? It must have been 14. It was 13, 14, 16. Where's 14? I'm looking at my monkeys. You see, this is. I'm gonna get this here. This is the 14 monkey. You have that one?
Well, no, I just missed that one. So I must have joined in 14.
Right, that's the one.
Yeah, yeah.
I still got this one here. Oh, fun times, startup times. So now we're here, and like you said, we're senior content developers. I guess senior means we're old, right?
That applies to me, yes.
It applies to me too. You look younger than I do. So what is this?
Not if I turn my head, you know.
Well, then you're transparent. We discussed this the other day. There's apparently something greenish in your hair there. So you don't happen to have a green coffee mug like you had yesterday when you did a stream with Glenn Stevens?
No, I've got this great big silver one, which may be transparent. I'm not sure.
It is kind of transparent. Yeah. So in case you don't know, we have got streams. So Kym has got a stream, I'm doing a stream, our colleagues at Xamarin University, they have got streams. Make sure to subscribe, to follow. You can learn everything about Azure, about mobile development there. Always worth visiting these. So this one here today is, however, separate from Xamarin University. This is my private contribution to this. So like I said, what I did, or what I'm planning to do here, is I was looking at my son's homework, and I quickly want to bring up a little picture, if I can find it, to show you what this is all about. It is. I see, now I gotta find it. Shouldn't you prepare these things when you're doing a live stream? There it is.
Is normally the way it works.
Copy, address, but that's just boring. It won't let me open another tab. Apparently I've got too many tabs open here, so that's what we're looking for. My internet is really fast. Wow, that's big. So this is what we are talking about. This is called I reckon a word puzzle. And so the challenge here is that you're given a list of words and you have got to find them in this grid of random characters. And that's what he was looking at. And he was missing out on 2 words and he just could not find it. And the whole family was involved. And I kept staring at this and said, well, there's Azure, and Azure has got a thing that is called Azure Vision APIs. And I was deep down in my thoughts thinking about artificial intelligence, and couldn't the computer just look at this and tell me where these words are? How hard can it be? Now, in retrospective, it's very hard. So there's a lot of code to write.
You're such a software engineer. Really.
It's that's why they pay us for the engineering part. And so I was talking to Kym, and Kym immediately volunteered to support me there. So what is your part in this?
Okay, so just backtracking a little bit, Renee said to me, I'm going to completely over-engineer my son's homework. And I was like, I'm in. So that was all I needed. And then he explained to me that we had this word finder. So it would have an array of characters, essentially. And we need to find words in there. I was in Barcelona at the time on a family holiday. But I was flying back to Australia the next day. So whilst I was on a plane with 3 small children, I wrote the algorithm which would basically, given an array of characters, go and find all the words and report where it found those words. So that was, and it's not that complex. It's got nothing to do with computer vision or AI. It's literally just processing a bunch of characters.
How long was that flight?
14 hours, maybe, before
14
the
hours.
stopover.
With 3 kids? You were all sitting next to each other?
Yes.
Okay, and you had your computer there and you wrote an algorithm to find these words in the grid. I think that's respect. Well done. So let me ask you that question. Is the algorithm actually working?
I think so. But having said that, when you said we're gonna stream this, I actually went and had a look at it again.
Okay.
And you know, whenever you look at your old code and you think, well, what was I doing? So there's definitely things in there that aren't great, but I think it works.
Yeah.
It's just probably not as efficient as it could be.
Oh well. We've got the power of Azure, so it doesn't have to be efficient, right? We've got cloud computing. Okay.
Exactly.
So we're gonna have a look at this in a bit, but before we get there, I would like to introduce the big picture. So you see, it's more than just one algorithm to find words in a 2-dimensional array of characters, because that would be too easy. Because that would mean, if I go back to the original challenge, my son's homework, what he had was just a sheet of paper. So all I would have was a picture. I was able to take a photo of that word puzzle that he had. And I didn't feel like I wanted to go ahead and now type every individual character into a program or into a text editor or something, because, I mean, then we could directly run your algorithm on that. But it's never that easy. So here's what I was thinking. I would like to be able to take a picture of this word puzzle and then somehow let the computer recognize what are the individual characters. And it must be pretty reliable, otherwise it would not work. And so what you see here on this screenshot is, well, it's a smartphone device, but really what that should represent is any kind of client that is capable of uploading a picture to the cloud. So that was the plan. We take this picture and we upload it to the cloud, and surprisingly this cloud is Azure. And in there we're going to do some processing. So once it's been uploaded, we're going to use something like Azure Functions, and we let Azure Functions work on this image, split the image into individual sub-characters, and then pass these sub-characters onto a Vision API. That means some artificial intelligence there that we will have to train, that we will have to make recognize all the characters. And once it's done, when everything has been recognized, then it's going to hand it over to Kym's super efficient algorithm.
Yes.
Which is then going to find the words in that puzzle and is, I guess, supposed to tell us where these words are, where they are starting. And then the client must have a way to retrieve these results, because this is nothing that can happen synchronously. We're going to upload the picture, it's going to do its magic, and eventually we're going to get the data back. And then we can display the results. I guess, so this homework assignment was like 5 weeks ago. I think my son is done by now. But in looking forward, in about maybe 4 or 5 weeks, we should have a completely working solution here to support him and verify that his assignment was done correctly. So that's the plan now. So if you don't have anything else,
super efficient.
That's efficient, right? So should we do the math? How much that cost us? So
no,
no, we should.
That would be a very bad idea.
2 people working on that. Anyway, if there anything else from your side, or otherwise, I'm going to switch over to Visual Studio.
No, I got nothing else.
Any comments? You see that I've got a cloud in here. I heard that's always very important. If you do something with coding, you should have a cloud in there. So I tried to put that in there. And I've got a cylinder, which represents the storage. So it's all there. We have a database. There's a lot of stuff going to be implemented here. Mm-hmm. Now, let me find...
I'm surprised. One thing I am aware of is that you're using a custom vision API rather than just the normal sort of vision. I think you're going to talk about that later on, right? When we dig into that service.
Once we get there, we can talk about this in more detail. But it's a very good question, because if you have used Azure, then there is this demo website where you can upload anything, and it can recognize handwritten text even. I guess that's what you're referring to, or it can detect text in pictures. So here's the thing. I initially thought about using that, and I think you brought it up initially. And I tried it, and it didn't recognize anything, really. I tried to figure out what is going on, because when I scribbled something and my handwriting is really bad, I wrote like "Hello World," and it would tell me, yeah, that says "Hello World." And then I just made it recognize like the H from "hello," and it had no idea what I was going on about. And then I tried just writing "world," and it wouldn't recognize "world." And I'm like, that's interesting. So what it does is it needs some context. It needs words, and it tries to figure out, okay, that's probably hello, that's probably world. So it's very probable that that together means hello world, but it's completely incapable of recognizing individual characters. And it has no idea about these. So that's why I went with a custom vision API there. But you see, that's number 5 here in that diagram. I don't know. Can take a bit until we're there.
Yeah.
Now, let's see. Where's Visual Studio here? Is it here? No, it's not there. You know this problem of having too many desktops? There's...
I'm aware of this problem.
2 monitors and I think 6 desktops. That looks like Visual Studio.
That is Visual Studio. I'm familiar with this.
What do you think about the font size? Should we bump that a bit?
Yeah, I think you should pump it up a bit.
What are you always using? 130? Like that?
Yeah.
Even more?
I've got poor eyes, so
I can go to... What about this?
I think it's looking good. Yep.
Yeah? All right.
Yep.
So what are we looking at here?
We're looking at the code I sent you when I got off the plane. That's what we're looking at here.
I can totally imagine you disembarking the plane with your notebook. I'm like, hey, I gotta send this.
Yeah. It's like, can you just look after the kids? I've just got to send this email.
Yeah.
This is the basic code that does the solving. So once Renee's clever stuff actually works out what that image contains and all of the, actually decodes all the images of the characters into actual characters and ends up with an array of characters. This is the thing that then takes in a list of words and says, is that word in here? Where is it positioned? Where are each of the characters in there? So that's pretty much what this is doing.
So it needs the list of words, right? It needs that input.
Yes, it needs the array of characters, the grid of characters, and it needs a list of words that it's finding. So, technically speaking, we could, use some sort of dictionary to start going through, but that seems pretty intensive. So
I like that idea.
Yeah, I like that idea as well, but it feels to me, I don't know a way of making that efficient. It feels like it would be very inefficient.
It's probably something that you could plug in on the next flight back to Seattle.
Yeah.
Yeah, I'll make sure to call you, but let's go with the first iteration now, maybe.
Cool. So should we're just talking it through, what the algorithm actually does?
Yeah, I think so.
Yeah. Okay, well, first of all, we should point out that there's a few, what would we call them, limitations, a few rules that we go by here. Mm-hmm. So one of the rules is that you can use a particular character multiple times. Okay, so if I had food and fly, that F could be used in both of those. So it doesn't exclude characters it's used before. So that's one rule. The other rule is that it will look either up, down, left, right, or diagonal. So some word finders will allow you to sort of go up and then change directions halfway through the word. Mm-hmm. This one doesn't. This is just looking in a particular direction. Yeah. Which seems reasonable for your son's homework. You know what I mean?
Yeah. So does it support overlapping words? So if you have like one going horizontal and
Yep. Absolutely. Okay. Absolutely. All right. Let's have a look at the algorithm. So Renee's given me a live share here, which is pretty cool. So hopefully you can see, if I use the right window here, I can highlight bits of code.
Somebody's in my code.
That's me. I'm in your code. All right. So let's work through what we have here. So this is the solver. So with the solver, there's a few structures set up just to return the information and structure things. So working from the top, we've got a grid position. So all this does is just as a struct which represents a row and a column. And then we've got a letter at a position, which is basically saying at a grid position, there's a particular letter. Okay. So these are just things that users internally. The thing that we're going to return out of here is a search result. So a search result basically says, did it find it or did it not find it? And it has a position where it's starting from, what word it was looking for, and then an array of those characters, basically. Right? So the letters inside of them. So that's how we get the result. Now, the way it kind of works, it's very brute force-ish. So in other words, it basically has the main thing that it does is, or the main algorithm here is, it searches for a word, it takes in a grid, so a two-dimensional array of characters, it takes in the word that it's looking for, and then it basically just goes through every row and every column. So it's going through, it's basically scanning through every single letter, and as it gets to each element, it starts searching at that point. So again, it gets that grid, the row it's up to, the column it's up to, and the word it's looking for. Okay. And this down here, search at position, is that algorithm that does this. And really, it's like I said, it's pretty brute force-ish, so it's not really doing too much other than the only clever bit, really, I think, is the fact that it basically starts at a character and it starts heading off in directions. Right? So it'll say, I'm going to start looking diagonally to the left, and then it'll say up, and then diagonally to the right. And it basically just goes and checks cells going up to see whether it's the next character in the word. And as soon as it finds out that either it's hit the end of the grid or the character it's found isn't in the word, then it bangs out and it goes on to the next area.
So that's the search at position that's doing that. Every search at position is searching this star-shaped pattern. Is that okay?
Yep, that's exactly what it's doing.
There's a couple of things in there that I learned here. So even if you're saying this is, what you say, it's brute force-ish or whatever, but there's a couple of things that I was not aware. I did not know about get upper bound, for example.
Right.
Yeah. What is get upper bound? What is that?
Well, that's basically how I'm finding. Okay, well, let's walk through this a little bit. Right. So we start at a particular point. We start going through the 8 directions. And I'll talk about how that works in a moment. And it basically gets its starting position. It works out which direction it's going. And then from that point, because it might be, say, the top left corner.
Mm-hmm.
And if it's going to look to the left, I don't know whether my fingers are backwards. If it's going to look from the left at that point, it's got to check whether it hit the end of the grid or the beginning of the grid. So get upper bound is basically telling you the upper bounds of an array.
Oh, so that's a helper method that you added? I did not see that.
No, it just exists.
It exists? Okay.
Yeah. Gets the index of the last element in the array. So it's basically just seeing if it hits because if it starts going outside of the grid, it just says, okay, well, it's not there. Mm-hmm. And so it breaks out there. And so it's basically just going through. And the bit I like about this is the way it works out its direction. Right? Because if you imagine a grid, it's going to start heading off in a particular direction. So what I actually did was I just tell it the deltas, if you like, of which direction it's going. So a little bit further down here, let's see if we can highlight a bit of code. Get delta for direction.
Oh, I get it.
So these are the directions. So it starts off going -1 to the left, -1x. So it's actually sort of going diagonally left, and then it will go -1x 0y. So it sort of starts going that way. So it actually goes around anti-clockwise.
So that's always pairs of numbers that it's going to. So it's always the 0 element in here from the X array and element 0 from Y. That's where it's going for the direction 0.
Exactly. It's going to start off with those two, and it's going to start going every time it steps to another character. It's going to go -1 to the X, -1 to the Y, and that will be the next character that it's trying to find.
I didn't want that there. Sorry. Okay.
Yeah. And then it just continues to do that. So these are kind of like, I don't know, points of the compass, if you like. And it basically just uses that to create a delta in a particular direction. So things that I didn't like when I came back to this, I really wish I didn't use variables like RD and CD, which basically means my row delta and my column delta here. So it's basically saying starting that point plus which direction I'm going in the row. So in our case, it would start off saying -1, -1. So it would start off looking one element back, one element up. So that's what it does, and then it starts having a look through there, checks the character, and it keeps on going around here while it's finding the character. So you'll notice that it will say in here, and this is where I've got a sort of saying I'm at a particular position in a word, so it starts stepping through the word. While I'm not at the end of the length of that word, it will then come and have a look. And if it either is out of bounds, okay, in which case it couldn't find it, or if that character is not the next character in the word I'm looking for, then it bangs out of here. Otherwise, it knows it has a match. So it says add a letter match, which basically then stores away the fact that it found a letter at a position, and it will keep on doing that until if it finds all of the characters, which means that it found as many characters as there are in the word. It says it's found it, returns a result, and we're good.
Okay, so I'm getting back the information I'm looking for a specific word, and it will always return me something, and it's going to tell me I found it or I did not find it. So it's consistent in that.
Yeah. So actually, if you go to the solver, I think maybe you have to run it from your perspective.
You mean run or go to the test program, you mean?
Yeah.
Okay.
Sorry, the program, yeah. So you can tell I was on a plane because I called it the Word Finder 2000. So this is the thing that actually uses this algorithm. So it starts off with an array of characters, effectively.
Kym, may I quickly interrupt you? Sorry for it. I just noticed that there is again an audio problem, so I'll try switching to my earphones once again. So we tried that before, but now it hits us again. I'm gonna give it a try. So you should be right in my ear in a second.
What a spooky thought.
Oh, okay, there you are.
Are you there?
Yep. So let's see. I hope this is working, and well, we'll find out. Yeah. Okay, move on, please.
All right. So so what we have here is this is really constructing our two-dimensional array. So that's a row, and that's a column of characters that we have.
So that would be what we have in, if I switch, not here, if I switch there for a second, this is where we would find there. So that's kind of the small version what you're showing there, just like 3 by 3 or something.
Exactly.
Okay.
So because you didn't give me very good specs, I didn't know how you were getting the data, whether it was like just a single string or whatever. So that's what I came up with. But then what I do, and this is super inefficient. I'm sure there's a better way of doing this. This is where I basically turn it into a two-dimensional character array.
Okay.
So
why did you what is the original data? So the OBNL fun sphere, that is a
list of strings.
A list of strings. Okay.
Yeah.
I don't think it matters.
I don't think so. The only difference it will make is how you're sending the data from your service, or when you recognize all the characters, how do you store that information? And therefore, what are you going to call in here? Do you have a list of strings, or do you have a two-dimensional array of characters, or is it a JSON blob, or what have you? Just depends on what you have.
Yeah. So when we started this, I had no idea at all. It's just I just had this idea of it should recognize characters, and so yeah. And so that's just populating the grid. This here is just actually dumping out a grid just for console writes, just to literally show what it does. And then it goes through, and this is where it actually says, these are the 3 words that I'm looking for inside of here. I'm looking for fun, fear, and off. And it'll basically search those, and then it'll output it. So give it a run. It should I give it a run. Let's see. I don't know if it's doing anything. There it's building. And is it going to find it? It did. It's tiny. Right. It's tiny. Can I bump the font size in a command window? I know I can do it in terminal.
So go up to the little box in the top left and go edit.
And then find properties, I guess. Cursor size, font, and maybe 24. Yay. How's that?
Beautiful. That's good. So what it's doing is it's dumping out that grid of characters there, and then it's showing the results. So you can see it found fun at 1, 0. So that basically means...
I just resized you. Sorry if you noticed that. By accident, I was with the mouse on the stream window and I moved you off screen. So I'm just getting you back, sir. I'm sorry for that.
So what it's doing is it's basically saying it's found fun at 1, 0. So that means it found it at row 1, so 0 based, 0 character. And then it lists out the characters. So it found it at 1, 0, 1, 1, 1, 2. And so that's the 3 characters across there.
So I wanted to show that here, but so it's this one here. That's the fun.
There we go. Right, exactly. And then the next one, fear, is on row 2, starting at character 0. And so it basically outputs that information for you about what it found.
I don't see off. Where's off? Oh, 0, 0. So that's going vertically down. There it is.
That's going vertically down. Exactly.
What made you go for row first? So my background is game development. It's always X going right and Y going up.
Yeah, I don't know, because I'm looking at it now and I'm thinking, that's a weird way to do it. So that's the kind of thing you do on a flight. So you could easily go and reverse that. Yeah, because I kind of agree with you. I would normally go the other way. But for some reason I wrote it this way.
But then you're from Australia, maybe that...
upside down.
Okay,
exactly.
that joke had to be, sorry. We're gonna cut it out. Yay, so this is working. And People can find this online, by the way. So if you look at our screen here, you find that all of this is available on GitHub at Grumelur, and that's how you pronounce it, Kym.
Yes, thank you.
/ word puzzle solver. So you can find the project there, and it includes all the code. But I think it's just boring to look at the completed solution and run it, because I doubt that, or maybe your kids also have got the challenge of doing a similar homework assignment, then it might be interesting. But I think building that thing and following the decisions, why did we, and how did we decide certain things? Why did we choose a specific technology? I think that's something that you can learn here on the stream. So I invite everybody to stay. So going back to this solver here for a second, we had this discussion yesterday, and we said we're not going to go into any details, but really it's something I've been thinking about. So you went for struct here, and I said, I don't know either. So when would we use a struct? When would we use a class? So this is something that I keep thinking about. The opinion was that, what you said was that this is something that it could keep on the stack if it's small enough and it's more efficient. But I think that's a great question. When would you go for a class? When would you go for a struct? Because you can do pretty much anything that a class can do with a struct. And so,
well, actually, I've just got, because you asked me about it yesterday, and I just kind of instinctively did it. It felt to me like something which is just holding a small amount of data for, should just be a struct. It just seems lighter weight. But it turns out I look at the documentation, Rene.
Oh, you did?
The framework design guidelines here, and it says, consider defining a struct instead of a class if instances of the type are small and commonly short-lived or are commonly embedded in other objects. So
what does short-lived mean?
It means, I don't know, they're coming in and out of memory a lot, I suppose. You're creating and destroying them a lot. It says avoid defining a struct if it logically represents a single value, like an int or a double. It has an instance size under 16 bytes.
Okay, how would I know that? That's already something that is, I'd say, pretty much impossible to determine, 16 bytes.
Wow.
But you can just estimate it, right?
Sure. It's immutable.
Which is not the case here. So having properties makes it mutable.
Yep. So it's saying avoid it if it's immutable. So that's okay. We're all right there.
So avoid it if it's immutable. Avoid it if it's immutable.
Yeah.
Okay. Good.
Yeah. It will not have to be boxed frequently. So I'm assuming what that's referring to is it's not going to pass it into any crazy APIs where it's going to, have to, like create wrappers around it, I suppose. So I think it's probably okay to be a struct.
That makes it a struct. Because I found myself using structs pretty often in the past, and then at some point I always ended up converting them to a class, and I'm currently trying to think about the reason I did that. There's something you cannot do with a struct that you can do with classes, but I don't know. I don't know what, but here it's working pretty well. Okay, so interesting excursion. Thank you. Thanks for looking that up. So that's our word finder. And if I go back now here to my image, to my flowchart, where is it? This one here. So we got, if we look here at number 6, this is where this word finder will be plugged in. This is where we're going to use it, or puzzle solver. That's where it is. But until we get there, we've got 5 other tasks to complete. And now that you talked me through the solver, we realized that we learned that we have to provide the array of characters. We also have to provide the words that it's actually looking for. And what we are starting with is really just an image. And when I first started this, I was naively thinking, well, I'm just gonna take a picture and then Azure is gonna do the rest. I'm just gonna use Kym solver and I'm done. And only then did I realize that there's so much more to do to make this happen. Because let's go through this. What would we need here? So we start by taking a picture, and I'm not even going into that part where I want to write let's say a Xamarin or Xamarin Forms or any other kind of mobile client app there where you can access the camera or anything. So I thought, let's start one step later. Let's start the moment we have that picture, and then we can leave it as an exercise to the viewer to write a Xamarin Forms mobile app. I heard you were pretty good at doing designs for Xamarin Forms mobile apps. You just showed me something. So maybe I'm gonna add point number 7 here, and you'll be back at the end of the stream and you're gonna show us a nice Forms app.
We'll do it. We'll do a nice Forms app at the end. Absolutely.
And while you're at it, please an Apple Watch app, because I struggle building one.
That is so over-engineered. It's like here's my kid's assignment, and here's the result on my watch. We'll try it.
So actually, my son is gonna have computer science lessons starting end of the year. And I was talking to him, say, you gotta show this. So it's like, Daddy did something. as if anybody would care. So back on topic. So we're starting with this image. So what we need somehow is to find a way to upload that image. So the first piece of data that we have is a binary image. And when we upload it, we got to store it somewhere. And I decided to go with a blob storage, as you see here in this picture. And that's now a bit of out of order here. I want to talk about this blob storage thing here, because what we just did here, we ran this puzzle finder, we ran this locally in Visual Studio, because what we want to avoid is, if we're developing a cloud solution, we don't want to constantly deploy all of this to Azure just in order to try something, right? That would be kind of a long development cycle and would mean a lot of coffee. So instead, we want to run this locally, and there are certain requirements if you want to do this. And since we need a storage database, I want to talk about the storage emulator. And I guess you have got this running up on your machine too.
I do.
You do, and it's working great. So what is this? Well, if we look at Azure, if we log into the Azure portal, which we'll do much later in one of the stream episodes, we'll find that you can create a storage account. And a storage account is, what is all in a storage account? There's blobs, which is binary large objects, and there's other features in a storage account. So you can have databases, they belong to the storage account, right? SQL databases. We have got, what's the other database? Cosmos DB is in there, I think. And then does file storage belong to it? Shared files is part of it. So there's a lot of different things that you can do with this storage account. And there's a local version of this environment, and that is the storage emulator. And you can use this, you can connect to this just like you would connect to the online version of it. And you can store blobs, you can store files. And that's what we need here. So if you want to build and use this project locally, if you would like to follow along while we're building that, or if you just want to run the completed version, you'll need that storage emulator. And I guess the easiest way is to just get over and Google on Bing and look for how to install the storage emulator. And you're going to find our Microsoft documentation there that tells you to get this. Now, if we look further down here, I wonder if it is in there. Or maybe it's not. That's not it. There's another one. So the storage emulator is available for Windows and for Mac, right? Do you know that? I think it is.
I definitely know it's for Windows, because I predominantly use Windows. I haven't installed it on the Mac.
That's what I have here, but I think I read about this. And the emulator, this is something that surprised me when you install that. I was always waiting for something to happen, because I mean, that's what you're used to. You install something on Windows. I kind of expected a window to appear with some UI, but that's not the case. So the emulator is it a service like thingy? Is that what we could call it? Or how do you think about
it? I guess so. Yeah, it's you know, it's a full Azure storage environment sitting on your local machine. Yeah.
Right. And if you want to access that, I'm pretty sure you can do this via the command line if you absolutely wanted to, or you can get another add-on, and that is the Storage Explorer. So it's the Emulator on the one hand, and it's the Explorer on the other hand. And the Explorer is something that allows you to see what is in a storage account. So this is the second thing that you should install if you would like to follow along. This Storage Explorer is not limited to the local storage emulator. With that, you can explore, well, any storage, be it locally or be it on Azure. You can log in with your Azure credentials, and it's going to give you access to that. And this, when I originally looked at it, was only available for Windows. It was long ago, but now it seems like there's also a macOS and a Linux version. So that's good to know, because everything that we build, and I think, well, your puzzle solver doesn't really use any fancy APIs, but everything we build will be based on .NET Core. So in theory, this should run on all platforms. I haven't tried it on the Mac, but it's working on Windows. So everybody go get that Explorer and the Emulator, and I want to fire that up here. This is what it looks like. This is the Microsoft Azure Storage Explorer, and I can probably zoom in a bit here. So you see, it shows us local storage accounts. It shows us remote storage accounts. Like here's my Visual Studio subscription in there, and I can access everything. And one of the first things that we need locally is to create a blob container. A blob container is, I like to think of them as a folder. I don't know if that's the correct thing to say. So the way this works is you've got, as part of the storage account, you've got these blob storages, and a blob can be, well, it can be anything.
Can be anything.
Like any binary text, whatever you have. You want to store something, you want to make it available to the world. So if you open up the Storage Explorer, you'll find that in there is this blob containers node, and you can right click here and create a new container in there. And you can give this container a name, and here I named it Word Puzzle Uploads. So this is where we will make the client upload our scanned or our pictures of the word puzzle to. And I don't know if it's showing anything in there. There should be one in there. It's refreshing right now. Let's give it a bit.
You're looking at your local storage now.
That's all locally, right?
And so that's amazing, right? That you can do all the Azure stuff, you know, on your local machine. You know, so you don't have to change your code when you put it up in the cloud, right?
Yeah. So essentially, all you have to do is change the connection string. Up there it was. So it showed it just the moment I moved away. It's always like this, right? You wait for it forever, and then when you click somewhere else, that's when it's starting to show data. So what I was to say is you're using a connection string to connect this, and the connection string for this one is actually pretty straightforward. I want to see if I find it somewhere. So here we have I got to look it up. I think it's just something like, so the connection string is called use development storage equals true. And you configure this in your Visual Studio project, and it's only going to use this locally. So the beauty of all of this is you're going to have this local config, and we'll be getting to that. You're working with a storage client library, and you just tell it, well, this is the connection string. And when you deploy the solution to the cloud, to Azure, and we're going to talk about continuous deployment too, of course, as part of this, it's going to read this configuration value directly from whatever you set up in Azure. So it remains secret on Azure, and locally you don't have to worry about updating any strings, and there's no danger if, say, I am using this here and I'm handing the solution over to you, that by accident you submit it to GitHub, and then the Azure deployed solution tries to access your local storage or something. That's just not going to happen. So this is pretty nice. So these, what you see here, are all uploaded images already from my tests. And now if we select one of these, there's an additional thing that is interesting in there. I'm going to open this up here. And I just realized that it is super slow. So I'm doing this the first time here with 2 people on the stream. and running Windows and running everything else on the same machine, and it's not quite responsive anymore.
Well, you're running Windows on your Mac here as well, right?
Mm-hmm. And I'm tempted to check what is using the most CPU, but I'm going to do this.
Do it later.
Yeah. So this is, you see this here, security warning, this file is potentially unsafe. Are you sure you want to open it? I'm not quite sure why it thinks that an image that I uploaded is unsafe. Yes, I absolutely want to open that. So going back to our word puzzle here for a minute. And I want to zoom out here. Can do this. So not only do we have to upload and store the image as part of this, what we also have to think about is, well, how is all of this aligned? Come on, I don't want to open it now. That's what it was asking me. So if you upload an image, you see that this image may contain other information. Like here, it's the title and it's the words that can be found. So when we upload this, we have to tell it, well, where does the first character actually start? We need to get information about the pixel coordinates here. We need to tell it what is the grid width, what is the spacing between the individual characters, and also important, what is the list of words that it should look for. So this is all meta information that has to be provided on top of the actual image. I know what you're thinking. You were probably saying, hey, Renee, can't it automatically detect the separators here and the vertical and horizontal lines? Am I right? No, you didn't think that.
Exactly what I'm thinking.
So this is something that bugged me for a while, and I tried something and I figured, no, that would be over engineering. I guess
you could do it, right? With enough code, you can do anything.
That's what I'm thinking. So the first thing would be, if I imagine I would be taking a picture with my phone, it would never be correctly aligned. That's the one thing. So we would have to figure out how to align that, and then it would have to detect edges, and it's kind of running AI already locally on your device before you upload it. And so I thought, I'm gonna skip this maybe for later. I put there a / to do. And / to do means never going to look at it again, right? That's what it is.
It's pretty much what it means.
Yeah, but getting back to what we discussed previously, so if I really end up doing a client for this, using your inspirational designs there, then what I would need is something on the client where you can like rotate and pinch and zoom that image and kind of align it to a grid and upload it then, and also provide a list of words. So for now, for this first iteration, what I thought was, well, if I upload an image, I will just have to provide this information manually. And I found something interesting about blobs. Big secret I'm going to share here. A blob is not just a binary large object. A blob has got support for something, you see it, metadata. So I learned this the other day. So my first thought was, I'm going to upload this blob image or this blob data somewhere, the image, and then I need I need a SQL database, or I need an Azure table or anything to store that additional info, and then somehow I would have to synchronize these. But it turns out that this meta information that I have here, it's just a name value collection. And you can store whatever you want in there. It's just...
Do you know how big it can be?
I have not found any information about any limitations.
Okay.
And I thought I'll probably run into something, but here's what I did. I thought I'm going to store things like, what is the height of each cell? What is the spacing? What is the width? You see, how many rows do we have? How many columns do we have? And all of this worked pretty well. And then I thought, well, let's push it a bit and see, can I also store a list of words that it's going to look for? And I thought, now somehow it's going to throw an exception at me saying that the value is too long, but no, not a problem at all. And I did a bit of research, and they even say if you have anything that is more complex data, convert it to base 64 and throw it in there and just store it. So I thought that's perfect. So everything up to here is something that we will have to provide when uploading this picture. That's a bit of a manual process. And as you can see here in the background with this word puzzle, I did a lot of trial and error to figure out a proper spacing and width and height for this particular puzzle that I'm using here for testing, which is a bit of a bummer, but I mean, can always be improved. And not only can this data be provided for uploads, once you process a blob, you can update that dynamically. So even when our full code is done processing the image, it would just write back the results here into that blob. You see it says here results. And eventually it's going to put this information in there, which is what your solver returns. Just convert it into a JSON object.
So it's all just self-contained.
It's all self-contained. So this blob contains everything. So I got away without using a Cosmos DB or SQL or whatever other DB.
I actually just did a Google on Bing, and found out that the total size of all metadata pairs cannot be, or can only be up to 8 kilobytes in size.
8 kilobytes. Okay, where did you find that? Is that documentation?
It's in the documentation.
Okay, so that would be. Is that 8,000 characters?
Yeah.
No.
Sure. 4 Unicode, depends if you're doing Unicode.
I don't think it supports Unicode. Did you find something about converting it base 64? Does it say something about this?
I didn't see anything about it.
Because I presume it's 1 byte per character. That would make it 8,000. Okay, but still, I mean,
it's a lot of data for what you're doing.
Yeah.
Yeah.
I mean, you could always file an issue and asking me to convert it and refactor it to use Cosmos DB if we ever solve bigger word puzzles. Okay, so that's kind of a requirement that we have here, and this is what we're going to work on when we. I guess no, we're not going to start that today. So I'm looking at the clock. We're about 1 hour in. So this is one thing that we'll be working on probably next time. And the other thing that we're looking at, once that we found what is the size of the individual cells, we need to split that image. So that's the next thing. We are storing that image and somehow we need to split that. So what I'm talking about here are all requirements before we can do the actual detection. And so how would we split that? What we need is a way of taking any kind of image data and turn this into sub-images. And I did a bit of research, and it turns out that the .NET Core has got everything built in. There's system.drawing. Have you ever worked with that?
Years ago, yeah.
Years ago?
Yeah.
Right. So they ported this over cross-platform. It's still the same. And then I was like, great, I started with that. And if you read through the documentation, you'll find that you find references left and right. And I ended up at a blog post by Scott Hanselman. And of course, that's where you always end if you search for something that is about .NET and C#. And he's saying, yeah, it's all there, it's great, but you should not use it. So I'm like...
What was the reasoning for that?
The reason was that he says it's limited and there's just better ways of doing it. You know, he's always doing research on great libraries and what are other people building. And he pointed me to something called Image Sharp by 6 Labors, which is what we see here. And again, I want to try if I can zoom here. Let's make this a bit bigger. Have you worked with Image Sharp, any chance?
Never.
This is amazing. I immediately had to, you know, if you're so excited about it can only happen to nerds, right? You're so excited about a library that you immediately have to go to Twitter and say, this is the best thing I've ever used in my life. This was one of these experiences. So this is an image library that works completely without the use of system drawing. And it does everything you possibly want to do with an image. And I had no documentation. It's a bit limited there. But I installed that package. Yeah, go ahead.
It's an open source library, though.
You can
access the code for.
Yeah, you can access the code. It's available on NuGet, and it was this wow moment. So I want to show you what this is going to look like. And again, this is something that we may not be starting today. So I want to keep this intro session here rather short, and then next time start with the code. But the way this works is, and I want to see if I've got the code somewhere. The way this works is that, yeah, I'm going to move this over here. There we go. Windows coming.
Windows coming. Yes.
Slowly, there we have it. Get rid of everything that we don't need here. No properties, make this a lot bigger. So just we see what this code looks like, how you work with this. Whoop, let's scroll there.
So this is your code that's using image sharp?
Yeah, it is. And this is something that I'm going to show or give a preview of what the completed version is looking like. And I'm planning to then go through the individual steps and how to really do this, how to install all of this and how to use it. But just to give an idea of how this is working. So you start with an image, whatever that is. And then you can clone that, you can work on this image directly in memory. It supports everything. It's bitmap, JPEG, PNG, GIF. I learned that the other day.
Don't start the GIF war.
Well, there is no war, right? It's obviously, apparently it's GIF now. It's still GIF for you?
It's still a GIF for me. Yeah.
I have to admit it's also GIF for me, but we're the only ones, I think. So anyway, it supports everything, and then really without reading any sort of documentation, it's one of these libraries where you just go, you look at it, and you look at auto completion in here. And you're like, well, I wanna save that maybe. So there's a save method. Great. I wanna change it. Then you just kind of start looking for what are other words for changing, and you figure, well, mutate sounds like you could change it, and you go for mutate, and it tells you that you have a graphics context here, and you use that context, and again you just type dot, and it's like everything is there. Oh, look at this. I don't know if you can see it. Binary, black and white, binary diffuse, draw polygon, draw lines, it's all there. And so without further research, immediately I got this this feeling of, hey, I'm successful here. I can draw a rectangle around this. I can crop this image to whatever size I need. And I just end up saving this as a PNG. Job done. And this was like, wow. And so I have to promote this library. It's amazing. So a library is well done if you can explore it without any documentation. Then I think it's spot on. So that's another thing that I have to work on then. Then back to the flow. So we're going through this here step by step. We have the blob storage covered. We need to talk about, well, how can we upload to a blob storage? We got to introduce the client libraries that are available for Microsoft there. We got to talk here, you see the flashes about how do I create Azure functions. And again, we will learn that there are tools available that allow us to use these functions locally to do all the development directly on the machine and then deploy them to the cloud. We will have to discuss Custom Vision API, and I'm going to bring that one up too.
I'm looking forward to that one.
That is, so I'll give you a preview of what to expect. Please. To see this here, ZZZ. So this is, there will be quite a lot of work to do there, because again, initially this naive approach, it's like, yeah, it's an array of characters. How many different fonts are there? So I didn't take that into consideration.
You have to train it for all of these different fonts.
I have to train it, and here's what I did. I ended up, initially, I manually took screenshots of the fonts. Like in Windows, you open up this where it shows all these words, and you manually try to crop every image. And I'm like, this is going to take for ages. So additional challenge, and I'm going to talk about that too, of course. There's a tool that allows you to take any true type font, extract all the individual characters, save these characters as images using a shell script, and then save them and then upload them. And here in this Custom Vision API service, you will then have to tag them. And as you can see here, in total I uploaded 32 different fonts and font sizes. And then you go through them and you tell them that, well, hey, this is a set, and you do this 32 times for 26 characters. And by the end of the day, so this is pretty amazing. If you look here at performance, you see I've got, and again, we're going to go into all the detail. I did 12 training iterations in total, and I ended up with a precision of 94% now. So that's what the recognition rate is, and hopefully that is going to give us the results that we want, and we'll be able to correctly predict all of the characters in there.
So are you saying your son can only ever get 94% in his word finder assignment?
Well, let's talk about what are the different grades. So what do you have in Australia? We've got 1 to 6 here. 1 is best, 6 is worst. Americans have A, B, C, or how does that work?
We do A, B, C.
We do A. What is A is best?
A is best.
And it's going up to where? C or D?
Yeah, to E. E. So D, C is a pass. D is sort of like needs work. E is a fail.
Okay, but that means with 94%, that will certainly mean an A.
He will get an A. Yeah.
Right.
Yeah, so that's okay.
So mission accomplished, right?
You've been a good father.
Yeah. And I think if he's unhappy with the results, I'm going to invite him to upload more fonts and categorize them, and just retrain the model. By the way, afterwards, once I was done with that, I recognized that, hey, there's a training API. So in theory, we could write a client to upload these and automate that process. But
cool.
But you know, things happen. So I did not do that. So that's this one. And eventually we got to find a way to return everything to the client. So that is the project that we'll be working on. And I think we're gonna make this the first part, kind of the introduction. And next time it's going to be all about coding, starting with the first part about the uploading, introducing the client libraries that we need there, dive into the code, the fun part.
And is that going to be uploading from a mobile, or just taking an image that exists already and just pushing it up?
Right. So it's going to take, first iteration, it's going to take just an image. And I'm going to use the one that we have seen here, that big one, as a test image. Because like I said before, the hard part is really to figure out all the spacings, and it took me a while. And so if I just let somebody take a picture and use that, you have to find out those values, and that's very time consuming. Yeah. So this is something that could use, but I can totally imagine if we had like a client, a mobile client project for that, where you could, I don't know, maybe have a way of creating a grid that you could zoom and rotate, and you would kind of align that grid on top of the image. Yeah. And it would know how to split the image and figure out the sizes there.
Yeah, kind of like those apps where you take a photo of your receipt and it sort of squares them all up and de-skews them.
Right, exactly. Have you ever done something like this? Preferably cross-platform?
I've used one. I've never written one.
Are you aware of any libraries that could do this in a Xamarin Forms app by any chance?
I'd have a bet that Image Sharp could do it.
Well, Image Sharp could do the splitting, and you say drawing this, but we would have skewing. We would need what I'm talking about is about like creating an overlay. So you would overlay a grid on top of the picture that you could actively pinch and zoom and rotate. Does that make sense? What I'm saying?
Yeah, we could do that.
Maybe with Skier Sharp?
Sure. Yeah.
I have no idea. I've never used that. Have you?
I have used Skier Sharp, yeah.
Yeah?
Not to do what you're talking about now, but yeah, I think we could easily do it.
So
famous last words, yeah. Easy.
We could easily do that. So great last words, and I think so that's the plan, and I'm gonna set up a new event that will be next Thursday, maybe with, maybe without Kym, don't know yet, we'll see. And there we're gonna start coding, but I'll count on you to be there for the last episode for the client then.
for that bit that I said was really easy.
Yeah, for the easy part. I'm gonna back to that.
Yeah. Okay, we do the hard bits.
I'm gonna send out a tweet now. Kym said it's super easy. All right. So I'd like to thank you for supporting me here with that puzzle solver. And I can tell that the algorithm is indeed working. I got to do some research here on the custom API before I'm going to do this live here on the stream. Otherwise, it's going to be a big fail. But it will all work. It will all be super easy. So with that, I'd like to say again, thanks, and maybe we'll meet again here. Make sure to subscribe to Kym's stream over there. Follow him.
And
no, the other way.
Stream?
I'm there.
That way.
Did I not mirror you?
No.
What happens if I point to the left? That's my left here. That should be your left if you use here. You know what? I gotta fix that next time. Oh man. All right. So then let's switch here to the closing screen, and we'll be back next week. Kym, have a good
See you
night
later.
and see you. Bye.
Bye.